about 350 million years ago. Long before the age of dinosaurs, the Earth was a vastly different place. There were endless tropical swamps filled with lush, flowering fern plants. The air was characterized by extremely high humidity and oxygen content, creating ideal conditions for life to thrive. However, it was not the form of life we know today. The Carboniferous period was a strange, otherworldly era dominated by giant insects. The ubiquitous swampy, tropical forests absorbed carbon dioxide through photosynthesis and released a large amount of oxygen into the atmosphere, causing the oxygen content to reach a record high 35%, more than 1.5 times the safe level for humans. Such a high oxygen content served as a powerful energy source for the organisms in this primeval jungle world. It was an excellent period for early vertebrates that had just started to evolve and were not yet well adapted to life on land, as well as various invertebrates. They could grow to astonishing sizes. At that time, giant centipedes were as long as a small car. Dragonflies as big as eagles soared through the air, and scorpions the size of bulldogs ruled this swampy jungle. The Carboniferous period was a time when giant insects ruled the earth. Surviving in this period was no easy task. If you were in the Carboniferous jungle, it would turn into your worst nightmare. The first thing you might feel is dizziness and confusion, caused by the overly high oxygen content. The oxygen was so abundant that even a tiny spark could ignite the damp wood. Looking down, you might see your feet slightly sinking into the swamp, given the high humidity and swampy environment, which were typical features of the Carboniferous period. His was a common occurrence, but the truly spectacular sight was actually above your head. If you looked up, you would see something resembling a bird flying overhead. Their wings made a loud buzzing sound, and you could feel the vibration in the air. These were giant prehistoric butterflies, called megatypus. The average wingspan of a typical individual of this species was 40 centimeters, and the largest specimen could reach 55 centimeters, almost 10 times the size of modern flying insects. Megatypus was one of the largest beneficial organisms in the Carboniferous period. Their name means ancient netted wings, referring to their complex wing patterns that resembled delicate netting. Besides the two pairs of wings with bright patterns, these insects had some small bumps near their heads, which might have played a role in stabilizing their flight. They had a proboscis on their heads for sucking the leaves and branches of plants, which was an early example of adaptation to this feeding method. Besides their huge size, Megatypus was not scary at all. They were harmless herbivores, only interested in nutrient-rich plant foliage. A terrestrial predator in the Carboniferous period was completely different. It was a deadly threat to anything in its path. You couldn't miss it because it was the largest scorpion ever on Earth, called Pulmonoscorpius. It could reach a length of 70 centimeters. For comparison, the modern-day largest scorpion, the emperor scorpion, can barely reach 20 centimeters in length. Pulmonoscorpius had a huge body covered with a hard exoskeleton, which could protect it from attacks by other predators. Its powerful pincers were equipped with sharp claws, enabling it to grab and trap prey. At the same time, its curved tail, with a stinger, meant a death sentence for the captured prey. Under the pressure of a lack of prey, Pulmonoscorpius was an active predator, usually preying on smaller amphibians and reptiles found on land and in water. Its adaptability to the water depth environment made it a successful predator in its ancient habitat. And if it was hard for you not to notice this giant scorpion the size of a bulldog, it could easily spot you too. It had two pairs of eyes, two of which were used for spatial perception, and the other pair of lateral eyes might have been used to detect light. In addition, its body might also have had sensory receptors, further enhancing its ability to navigate and locate prey. If you weren't afraid of spider-like animals before encountering this nearly 70-centimeter-long venomous scorpion, you might develop a new fear after that. Now, let's return to the Carboniferous sky. Besides harmless prehistoric butterflies like Megatypus, we would also encounter beneficial predators. This predator might look familiar, because its descendants still exist today: the dragonfly. However, these dragonflies were incredibly huge. more than 10 times larger than their modern counterparts. Meganeura was one of the largest flying insects of all time. It didn't look too different from an ordinary dragonfly, just much bigger. Its wingspan could reach 65 to 70 centimeters, and its body length could be 40 centimeters, comparable in size to a modern peregrine falcon. More than 300 million years ago, these giant insects were formidable aerial hunters. They held the title of top predators in the Carboniferous sky until the end of the Permian period, when the first gliding reptiles appeared. Indeed, their large compound eyes provided an almost 360-degree field of vision, allowing them to spot prey from above and below. In addition, they had spines and strong legs for catching prey, all characteristics of highly aggressive and dangerous predators. It is believed that their prey often included the giant butterflies mentioned earlier. Their adaptability to different environments enabled them to adopt a dual hunting strategy. They could lie in wait like perched on a watchtower, ambushing potential prey, or actively chase prey in the air. They were fast and agile predators, good at making flexible flight maneuvers in the air, and avoiding obstacles when chasing their targets. Although giant dragonflies had no powerful opponents in the air, they faced many challenges in surviving on land, even for the powerful Pulmonoscorpius, especially when facing another behemoth, Arthropleura, a giant among terrestrial invertebrates. Its appearance and size were enough to scare anyone. It was the largest millipede ever, and also the largest terrestrial invertebrate in the history of insects. Smaller individuals of this genus could reach a length of 30 centimeters, while the largest specimens were astonishingly 2.6 meters long and weighed 50 kilograms. In contrast, the longest millipede alive today, the Amazonian giant centipede, can only reach 33 centimeters in length. Their bodies were composed of 30 segments, each segment up to 50 centimeters wide, and each segment had a pair of legs. Like many detritivores, Arthropleura shed its exoskeleton periodically in the Carboniferous period. When the original protective shell could no longer accommodate its growth, a new and stronger one would grow. It is believed that Arthropleura had an extremely durable protective exoskeleton to resist attacks from predators. However, it's worth noting that conflicts with other animals were extremely rare, because there weren't many predators in the Carboniferous forests. Even the giant scorpion might be wary of the millipede, which was several times larger than it. So far, no fossil fragments of the head and mouth parts of these giant millipedes have been found, so the diet of larger individuals remains uncertain. It is speculated that juvenile individuals might be strictly vegetarian, while adult individuals might occasionally eat carrion or even prey on small animals. But the uniqueness of the Carboniferous jungle didn't end there. In the swamp, another predator lurked, waiting for small reptiles and amphibians. It looked like an incredibly large spider, although it was not actually a true spider, but a distant relative. The sea scorpion, called Megalograptus, had a striking resemblance to a spider, which initially misled paleontologists when they first discovered its fossil remains, prompting them to name it Megalograptus, meaning big spider. However, it took some time to realize that Megalograptus was a scorpion of considerable size, with a body length of up to 55 centimeters. Its unique body structure allowed it to adopt a feeding method called scavenging-type feeding. It would use its paddle-shaped appendages to scrape through the soft mud in aquatic environments such as swamps and rivers, catching and consuming small invertebrates like worms, insects, and smaller crustaceans. Occasionally, it would also prey on terrestrial animals, such as reptiles and amphibians. However, terrestrial animals might be faster than Megalograptus, so they were not easy to catch. It seemed that this sea scorpion would hide in caves or rivers, waiting for prey that got too close to enter its deadly lair. As for active hunting, its ancestor, Pterygotus, which lived on Earth more than 400 million years ago, was much more powerful. This species was not only more flexible, but also larger than the giant arthropods, with a length almost equal to the height of an average person, reaching 1.6 meters. Although it seemed already very large, It was still inferior to another representative of the giant arthropods, Hibbertopterus. The largest specimens of Hibbertopterus could reach 1.8 to 2 meters in length. Its broad and compact body might have made it the weight record holder among its kind. The feeding method of this giant animal was not much different from that of its smaller relatives, still the scavenging-type feeding method, but its food might have included larger reptiles and amphibians. This was not the limit of giant arthropods. The largest representative of this group was the Gecalopterus, which lived 400 million years ago. It could reach a size of 2.3 to 2.6 meters, making it one of the largest arthropods ever discovered. The main tool for defense and hunting of this giant animal was its claws, which might have been up to 45 centimeters long, and powerful enough to grab and easily crush prey. However, such a huge size did not mean a correspondingly huge weight, due to its simple anatomical structure. Although its length was comparable to that of a car, its weight might not have exceeded 100 kilograms. Not all organisms in the Carboniferous period were affected by the giant gene. In the humid prehistoric jungle, where giant dragonflies soared through the air and giant centipedes lurked in the water, there were also other organisms. There was an organism called Trigonotarbida, so small that it was hard to notice under your feet. They could be regarded as the prototype of the earliest spiders in history. Smaller individuals of this species were only a few millimeters long, and the largest ones were only 5 centimeters. These were the oldest terrestrial arachnids known to science, emerging more than 400 million years ago. Long before the Carboniferous period, they had fully adapted to breathing air and no longer relied on water. Their appearance was not much different from modern spiders, with their bodies divided into the cephalothorax and abdomen, and their cephalothorax was protected by a carapace, thus earning the nickname armored spiders. These were some of the small predators at that time, preying on soft-bodied invertebrates like worms, for example. They might not have used venom for hunting like some modern spiders, but relied on their legs to catch and hold the prey before eating. They might also have eaten plants, like some mites that resembled Trigonotarbida. The Carboniferous period was a paradise for evolutionary experiments. Unique, giant, and often dangerous organisms dominated the sky and land. However, perhaps one of the most fascinating evolutionary experiments in this period took place underwater, giving rise to some of the most well-armed organisms at that time. Lepidocoleus was an ancient worm species that lived about 400 million years ago in the area of modern-day Australia. They thrived on shallow reefs, feeding on organic waste. This organism was only a few millimeters long and could only be observed in detail under a microscope. However, it also had a more memorable nickname, Excalibur worm. And there was a good reason for this name. In appearance, they were like fully armed knights covered with overlapping calcium carbonate crystals all over their bodies. These crystal plates extended along their entire body, providing them with extremely strong protection. Under the crystal layer was a lightweight exoskeleton, just like a knight wearing chainmail under armor. In addition, the Excalibur worm could curl up into a ball to protect its unarmored and thus vulnerable body parts. When it curled up, the sharp edges of its crystal-like armor would protrude outward, making it almost impossible for any organism to harm it. Penetrating its crystal shell was nearly impossible, and forcefully breaking its armor was not a good option. Evolution had endowed these worms with a perfect defense mechanism, but ultimately, it also came at a significant cost. Although this strong protection kept them safe from predators, the heavy armor limited their mobility, making it difficult to find food or migrate to new habitats. Therefore, the Excalibur worm did not leave any significant descendants. Their final extinction coincided with the mass extinction event. At the end of the Devonian period, amphibians began to diversify, and reptiles evolved into forms very similar to modern lizards. With a backbone, they were able to live and move on land. These amphibians were also very large, and some species were predatory, similar to modern crocodiles, with sharp teeth and a body length approaching 6 meters, just like modern crocodiles and alligators. Some of them evolved thicker scaly skin, thus solving the problem of water loss when away from water for too long. Most importantly, amphibians first evolved the amino acid containing eggs that could be laid on land. This breakthrough changed everything. These animals could now live away from water sources. The Carboniferous period gradually gave way to the Permian period, which began around 300 million years ago, only 50 million years before the appearance of dinosaurs. During this period, all the continents merged into a huge landmass called Pangaea. The first large herbivores and carnivores evolved in this period. Some of them looked like dinosaurs, but were actually more closely related to mammals and reptiles. A strange species was Diplosarhaspus, which was salamander-like in size, with an average body length of about 1 meter. But its head was shaped like a boomerang. Another newly emerged reptile was Dimetrodon, which could reach a length of 5 meters, and had a large sail on its back, possibly used for regulating body temperature. In the Permian period, mammalian groups gradually became dominant. The largest of these organisms belonged to the Gorgonopsians. They were giant bear-like animals, with teeth specialized for different functions. These animals could be either herbivorous or carnivorous, with sizes ranging from less than 1 kilogram to over a ton. One of them was Cynodont, whose name means dog-like teeth. These animals showed certain social behaviors, and fossil evidence indicated that they hunted in groups. In the ocean, fish with true bones began to evolve. Sharks and rays were also very prosperous, as were sponges and corals. On land, insects evolved adaptive mouthparts that could pierce and suck. But around 252 million years ago, the Permian period came to an abrupt end, with a catastrophic event that triggered a mass extinction. In 2001, scientists made a chilling discovery. A huge comet or asteroid might have caused this extinction event. The size of this asteroid was estimated to be between 6 and 12 kilometers. The energy released by the impact was 1 million times that of the largest earthquake in the last century. Scientists proved that the gases could only come from space, through the high proportion of helium hydride ions found in carbon compounds. In addition, there is evidence that present-day Siberia and China experienced large-scale volcanic eruptions millions of years ago. Volcanic ash clouds blocked the sun, and more than 3 million cubic kilometers of magma poured out onto the surface, covering the entire Earth with a layer of magma more than 10 meters thick. The combination of the asteroid impact and volcanic activity was likened to a deadly blow from a double-barreled shotgun. This series of events was called the Great Dying, which led to the extinction of 90% of marine life and 70% of land life. This Permian-Triassic extinction event marked the beginning of the Mesozoic era, the age of dinosaurs. In the early Triassic period, Pangaea was still a huge landmass, mainly consisting of vast deserts. The climate was hot and dry, surrounded by the huge ocean Panthalassa. Dinosaurs began to evolve in the late Triassic. When it comes to dinosaurs, people often think of huge creatures like Tyrannosaurus rex. However, new research shows that dinosaurs and their pterosaur relatives originated from very small ancestors. The evidence for this theory comes from new discoveries in Madagascar. A reptile fossil named Kangonophone coli, meaning little bug hunter, was found. This creature lived about 237 million years ago. It was only 10 centimeters tall, and was one of the first small animals found at the root of the ornithopod dinosaur family tree. It was an important discovery. This small-sized Asian event it experienced was a survival strategy of early ornithopod dinosaurs. In the early Triassic period, research on its teeth showed that this small creature was not an insect, so it didn't need to compete with its relatives for meat. In addition, research on the relatives of this small dinosaur shows that the feathers and other skin appendages later found on true dinosaurs and pterosaurs were likely initially for protecting these small dinosaur ancestors from the extreme climate in the late Triassic. That was when the first dinosaurs began to evolve. The Triassic period marked the rise of reptiles, mainly archosaurs, dominant lizards, and mammal-like reptiles. For unknown reasons, archosaurs had an evolutionary advantage over their mammal-like counterparts and evolved into the first true dinosaurs, such as Eoraptor and Herosaurus. In the Middle Late Triassic, dinosaurs were divided into two main branches, Saurischia and Ornithischia. Eoraptor was at the root of the Ornithischia family tree. It was only 91 centimeters long and weighed about 11 kilograms. It had long legs, enabling it to run fast. Its forelimbs had sharp claws, which helped it grab prey. Herosaurus was more advanced in evolution than Eoraptor because its lower jaw had a joint. It had a large skull with sharp teeth, like those of a carnivore, in its jaws. It was 3 to 6 meters long, with 5 fingers on its forelimbs and blunt claws. Styracosaurus was another early true dinosaur. It was about 2 meters long, with a skull as long as its femur. It had 13 to 14 sharp teeth in its upper and lower jaws. Its forelimbs were short with 5 fingers, and its long hind limbs allowed it to run quickly. Styracosaurus was a predator, weighing about 30 kilograms. Although this dinosaur was relatively small, it might not have had much difficulty dealing with larger prey. They were typical examples of the rapid evolution of carnivorous dinosaurs 225 million years ago. At the same time, the first herbivorous dinosaurs appeared in the fossil record. Hisanosaurus was a 1-meter-long dinosaur, weighing 2 to 9 kilograms. It had closely arranged teeth that formed a continuous edge for grinding plants. By the late Triassic, there were at least 15 different types of dinosaurs. During the Triassic period, the Earth's climate changed from hot and dry to a more humid subtropical climate. Forests composed of ferns, cycads, and conifers began to cover the Earth. The air was warm, humid, and had a tropical feel. At the beginning of this period, the breakup of the supercontinent Pangaea continued and accelerated. The northern part of Laurasia split into North America and Europe. The southern part of Gondwana began to split in the Middle Triassic. Antarctica, Madagascar, India, and Australia separated from the western part of Africa and South America. New oceans flooded the spaces in between. Huge mountains rose from the seabed, pushing the sea level higher and causing the water to spread over the mountains. It was this water that created the humid subtropical climate. The deserts began to turn green, and palm-like cycads and conifers such as araucaria and pine trees became numerous. The oceans were filled with diverse and abundant life. At the top of the marine food chain were marine reptiles, including the plesiosaurs with long necks and paddle-shaped flippers. There were also giant marine crocodiles, sharks, rays, ichthyosaurs, seal-like placodonts, ammonites, snails, and bryozoans, which were numerous in the ancient oceans. Coral reefs expanded rapidly in warm waters, and plankton increased rapidly, perhaps even to the extent of turning parts of the ocean red. The earliest known ancient birds took to the sky in the late Triassic, likely evolving from an early coelurosaur. Archaeopteryx had to compete for airspace with pterosaurs, which had been soaring through the sky since the late Triassic. At the same time, insects such as leafhoppers and beetles were numerous. Many of the Earth's early mammals scurried around at the feet of the dinosaurs. It was at this time that dinosaurs began to leave their mark on a large scale. Small quadrupedal herbivorous dinosaurs gradually evolved into numerous giants. The herbivorous sauropod dinosaur Brachiosaurus was up to 16 meters tall, about 26 meters long, and could weigh up to 25 tons. Another herbivorous sauropod giant, Diplodocus, was 27 meters long and weighed between 30 to 50 tons. The huge size of these dinosaur giants might have deterred a large carnivorous dinosaur that walked on 2 powerful legs and lived at the same time. This terrifying carnivorous dinosaur was Allosaurus. It was 7 to 12 meters long and weighed nearly 2 tons. It had 16 sharp teeth in its upper and lower jaws. Like many carnivorous dinosaurs in the Triassic period, Allosaurus continuously grew, shed, and replaced its 3 to 4 inch long teeth. This dinosaur was very fast, and models suggest that Allosaurus could run at a speed of 34 kilometers per hour. Fossil evidence shows that Allosaurus preyed on sauropod dinosaurs, while herbivorous dinosaurs would use their feet to smash holes in the bones of Allosaurus. However, some equally terrifying new predators emerged later. The North American Tyrannosaurus rex could reach a length of 12.5 meters and weigh 8 to 10 tons. However, some now believe that its weight might only be half of the above estimated value. But Tyrannosaurus rex was not alone in the category of carnivorous dinosaurs. In fact, it was on a par with two other sharp-toothed behemoths. One was Giganotosaurus from Argentina, with a similar body structure and weighing 8 to 9 tons. The other was Spinosaurus from North Africa, weighing 10 tons. Tyrannosaurus rex was a fierce and loathsome predator. To put it more bluntly, it could even be said to be rather unhygienic. Cardiogram experts believe that rotting, bacteria-ridden meat residues were often trapped between its closely arranged teeth. This meant that a bite from it could infect the prey, eventually leading to a fatal wound. Of course, this process would take at least a few days or weeks, and another Tyrannosaurus rex might well reap the benefits. After testing the skull of Tyrannosaurus rex, scientists determined that its bite force was between 1,500 to 5,000 pounds per square inch, and it could bite off chunks of meat weighing up to 225 kilograms. However, like Allosaurus, Tyrannosaurus rex also had problems in preying on its victims. It lived in the same area and period as some heavily armored herbivorous dinosaurs. Triceratops was one of the most iconic dinosaurs, second only to Tyrannosaurus rex. The name Triceratops means three-horned face. All Triceratops had a three-horned skull, with two huge horns above the eye sockets, and a smaller one above the nose. It weighed about 6.5 to 13 tons, and the largest Triceratops was 9 meters long from nose to tail. The top of its shoulders was about 3 meters from the ground. Triceratops had its teeth arranged in batteries. Each individual tooth was vertically stacked in groups of 3 to 5 to form a battery. There were 36 to 40 such tooth batteries filled with teeth, which meant that a single Triceratops could use up to 800 teeth. It had a narrow beak and a powerful jaw that could crush tough plants. Ankylosaurus was another well-known dinosaur. It was the largest ankylosaurid dinosaur and the last of its kind. It is believed to have survived until the end of the Cretaceous period. Ankylosaurus had a body covered with bony scales, a beak, and teeth. There were 4 horns protruding backward from its head, and the end of its tail was a club, which could be used to defend against predators. Given that Ankylosaurus lived together with Allosaurus, Tyrannosaurus rex, and other carnivorous dinosaurs, the tail club would be very useful. At some point in the mid-Cretaceous, ornithopod dinosaurs evolved into the well-known hadrosaurs. They were large, duck-like animals that fed on low-growing plants. They had a hard beak on their snout for tearing plants. It is believed that these dinosaurs lived in groups and could walk on 2 legs. By the late Cretaceous, ornithopod dinosaurs became even larger. You might think that Brachiosaurus and Diplodocus were already huge, but in the late Cretaceous, another dinosaur emerged. It might be the largest terrestrial animal ever on Earth, Argentinosaurus. Its length could reach 30 to 40 meters, and it weighed between 50 to 100 tons. It belonged to the Titanosaur group, which was the dominant population in the Cretaceous period. Like its early ornithopod relatives, it was a herbivorous animal. At that time, a strange new type of dinosaur also appeared. They lived 20 million years before the extinction of all dinosaurs, and were called Pachycephalosaurus. Their skulls looked very strange, with horns growing around the snout and the base of the skull. These horns might have been used to repel the last large predators, or even to show dominance among their own kind. Of course, more than 700 different types of dinosaurs have been discovered so far, but there's not enough time to introduce all of them in one video. During this period, there might have been snow and ice in the polar regions, with temperatures dropping to as low as -10 degrees Celsius, and 3 months of darkness in winter. Various dinosaurs lived in this polar region. In 2014, scientists discovered part of the skull and the upper and lower jaws of a mini version of Tyrannosaurus rex. This dinosaur was called Nanotyrannus, about 6 meters long. Scientists believe that many dinosaurs were covered with feathers to protect them from the elements. The relatives of this mini Tyrannosaurus rex were no exception. In fact, it is now believed that all types of Tyrannosaurus rex had feathers. Other dinosaurs, such as ceratopsians, hadrosaurs, and some small feathered predators like the parrot, like Oviraptor, and a small herbivorous dinosaur, Leolinosaura, also lived in this polar region. But their time was coming to an end. Although people often talk about the dramatic process of dinosaur extinction, considering that they survived on Earth for a full 165 million years, dinosaurs were perhaps one of the most successful vertebrates on Earth. In fact, some animals on Earth today are still descendants of dinosaurs. Modern birds are actually descendants of feathered dinosaurs. And you might be surprised to learn that crocodiles are the closest living relatives of birds. They share a common ancestor. These two groups are the only known survivors of the archosaurs. We all know what happened to the dinosaurs. Although they are extinct, their prosperity and dominance throughout the long history of the Earth undoubtedly make them one of the most successful forms of life on the planet.